Why supersonic travel disappeared, and may return. For 27 years, passengers could leave London after breakfast and arrive in New York before their body clock had caught up. Concorde crossed the Atlantic in under 4 hours, roughly half the time of a conventional airliner. It looked like the future, sounded like thunder, and flew at around twice the speed of sound. Then, in 2003, it vanished from passenger service. The strange part is that aviation did not forget how to fly that fast. The technology worked. The aircraft had already carried millions of passengers. So why did the future become slower? The usual answer is that Concorde was too expensive. That is true, but incomplete. Supersonic passenger travel disappeared because its greatest advantage could only be used on a tiny part of the world's airline network. It was not simply an aircraft problem. It was a system problem. And in 2026, that system may finally be starting to change. Speed was the product. Concorde entered commercial service in 1976. It carried roughly 100 passengers and could cross the Atlantic in fewer than 4 hours. This was not just a faster flight. For business travelers, celebrities, and wealthy passengers, it sold something airlines could rarely manufacture: more time. But speed came with a brutal engineering trade-off. Flying at around Mach 2 required a narrow, heat-resistant aircraft, powerful engines, and enormous amounts of fuel. Concorde carried far fewer passengers than the wide-body jets that were transforming mass travel. A Boeing 747 spread its operating cost across hundreds of seats. Concorde spread a much larger fuel bill across about 100. That pushed tickets into a luxury category. High fares reduced the potential market, a small market prevented scale, and the lack of scale kept costs high. But even that does not explain why supersonic travel stayed limited to a few routes. For that, we need to talk about the sound. The boom followed the airplane. An aircraft traveling faster than sound does not create a single boom only when it crosses Mach 1. Pressure waves form around the aircraft and travel toward the ground along its flight path. To people below, that can sound like an explosion, or a repeated line of explosions moving across the landscape. In the 1960s, governments and aircraft manufacturers imagined fleets of supersonic airliners crossing continents. But the public was being asked to accept the noise beneath those routes. Concern grew quickly. NASA records one dramatic event in 1968, when a military jet flying low over the United States Air Force Academy produced a boom that blew out windows and injured people. The incident became part of a much larger political argument over aircraft noise. In 1973, the United States put a general prohibition on civil supersonic flight over land into effect. Other restrictions followed around the world. Concorde could still fly faster than sound over the ocean. But over populated land, it usually had to behave like a conventional jet. This changed the economics of the entire aircraft. Its key feature worked brilliantly between a small number of coastal cities separated by an ocean. On many other routes, passengers would pay for a supersonic aircraft that was not allowed to use supersonic speed for much of the journey. The map of possible destinations collapsed. The world had built an aircraft that could outrun sound, but not the consequences of sound. A network that could not grow. Airlines become powerful through networks. More destinations create more connecting passengers, better aircraft utilization, and more ways to recover enormous fixed costs. Concorde never developed that kind of network. For most of its life, its identity was tied to a handful of transatlantic services, especially routes connecting London and Paris with New York. Only 20 Concordes were built, including development aircraft, and 14 entered airline service. The aircraft became famous, but fame is not the same thing as scale. Meanwhile, conventional airliners improved. They became more efficient, more comfortable, and capable of flying long distances non-stop. The mainstream airline business chose a different version of progress, not maximum speed for a few passengers, but lower cost and greater access for millions. Supersonic travel had won the race across the Atlantic. Subsonic travel won the market. The final shock. By the end of the 1990s, the model was already fragile. Then, in July 2000, Air France Flight 4590 crashed shortly after takeoff, killing everyone on board and 4 people on the ground. Concorde was grounded, modified, and eventually returned to service. But the accident damaged confidence in a fleet that was small, aging, and expensive to maintain. The aviation market was also changing. After the attacks of September 11, 2001, premium travel demand weakened. For a service dependent on a narrow group of high-paying passengers, the timing was devastating. British Airways and Air France retired Concorde in 2003. It is tempting to describe that moment as the death of supersonic passenger flight. But it may be more accurate to call it the end of the first business model. The problem is being rewritten. For decades, engineers treated the sonic boom as the central obstacle. Instead of asking how to make another Concorde, they began asking whether an aircraft could shape its pressure waves before those waves reached the ground. NASA's X-59 research aircraft is designed around that idea. Its long, unusual shape is intended to prevent shock waves from merging into the sharp pressure change associated with a traditional sonic boom. The goal is not silence. It is a quieter sound, often described as a thump, that communities may find more acceptable. That distinction matters because older rules were largely based on speed. A new framework could be based on the noise that actually reaches people on the ground. In June 2026, the U.S. Federal Aviation Administration published a proposal to replace the long-standing general prohibition with a performance-based approach. At the time of this video, it is a proposal, not a guarantee that unrestricted supersonic flights will begin tomorrow. But the direction is important. For the first time in decades, the regulatory question is moving from, did the aircraft exceed Mach 1, toward, what impact did the aircraft create below? If new designs can meet future noise standards, routes over land could become possible. That would expand the map, and a larger map could change the economics. What a return would really look like. Solving the boom does not solve everything. A new supersonic aircraft would still face fuel consumption, emissions, airport noise, certification costs, high ticket prices, and the difficult task of operating a new type safely and reliably. It would also compete with video calls, private aviation, and increasingly comfortable long-haul cabins. The value of saving 3 hours is not the same for every passenger. So the return of supersonic travel will probably not begin as mass transportation. It may start small, fewer seats, premium routes, and carefully selected customers willing to pay for time. In other words, it may resemble Concorde in one important way. The difference is that a quieter aircraft could have access to a much larger network. That is the real experiment. Not whether we can build a fast airplane. We already proved that. The question is whether we can build a complete system, aircraft, rules, routes, economics, and public acceptance, that allows speed to scale. Concorde did not disappear because the future failed. It disappeared because one spectacular machine arrived before the world around it was ready. Now, more than half a century after the first restrictions, engineers and regulators are trying to redesign that world. The next supersonic age, if it comes, will not be won by the aircraft that flies fastest. It will be won by the one people below can live with, and enough passengers above can afford. Next, how the shipping container quietly rebuilt the world.